In these examples, we're given two similar figures. We don't need to prove they're similar. They tell us that the figures are similar to each other. And this example asks us to find the ratio of perimeters and the ratio of areas. And that's what we're going to do as sort of step one for this problem. Now, even if they didn't ask us to do that, what I will always recommend you do in one of these problems is begin with one of these charts where we identify all of the different ratios we have to use. That's going to be really helpful for part two of this when they ask us to find a missing area or missing perimeter or whatever. So always begin with a chart even if they don't ask you to. So what I need to do between these two similar figures is figure out what I know about both of them. What corresponds, what matches up, and I can see that what I know about both figures is I know these two side lengths, 15 and 20, are corresponding sides. So I'm going to use that to begin my chart. Well, corresponding sides tell me the scale factor. And so in my chart, I'm going to begin with that. My scale factor, and it says to go from the small to large figure. If it doesn't say that, you can go in any order, but just check to see what order they want you to go in. My scale factor is 15 to 20. Now, of course, I can simplify that, and I would always simplify that. So my scale factor, the ratio between the sides, is 3 to 4. As we discussed in our last video, the perimeter ratio is the same thing. Now, I don't know what either figure's perimeter is, but that's okay. Their ratio is going to be 3 to 4, whatever their perimeters are. And then to find area, to get to that part of the chart, we talked about squaring each of those individual numbers. 3 squared gets you 9. And 4 squared gets you 16. So that will be the ratio of the areas of these two similar figures. So there's step one. And again, even if they didn't ask us to make the chart, I'd always recommend you start with that chart. Part 2 says, okay, now find the area of the small figure. Well, I can see the area of the larger figure was given to me. The area of the larger figure is 240 square centimeters. So I know the smaller figure will have a smaller area, of course. Well, to do step 2, I'm going to write a proportion. And I'm free to pick any of these ratios to use. However, I want to make sure I pick the appropriate one. And so since this problem is asking about area, not surprisingly, I'm going to select the area proportion, or the area ratio. And it seems like kind of a no-duh thing, but I'm surprised at how many people I see just pick any of these that they feel like, and it's not going to work if you don't pick the right ratio. So since they've asked us for area, let's use the area ratio. 9 over 16 is the ratio I'll start with. Since they've given me 240, which is the larger figure, that 240 will have to go on the bottom to match up with the larger number 16 on the bottom. And then I'm trying to find the area of the smaller figure, so I'll use an A on top. Okay, so let's go ahead and cross multiply to solve this proportion. So 16A would be equal to 2,160. Dividing both sides by 16, we already said we should get a smaller number than 240, and I come up with an answer of 135. I'll include a label since they gave me a label, square centimeters. Once again, we're given two similar figures. We don't need to prove that. The problem tells us they're similar. So I'm going to start with the chart. Even though they asked me to find the length of this side right here, which I'll just call x, I'm not going to jump right to that. I'm going to start with the chart. Always begin there, even if they don't ask for it. To begin the chart, I need to figure out what I know about both triangles, what matches up. And this time I can see they give me both areas. I know the areas of both of these figures. And so I'm going to use that to set up my area ratio of 7 over 28. And I'm putting that in the area column of my chart because, of course, that's area. Now, I always want to try to simplify first. In fact, if you didn't try to simplify and tried to just work backwards, we know we're supposed to take the square root. But taking the square root of 7 and 28 is not going to get you a nice, neat, rational number. So always try to simplify first. Sometimes you'll have to deal with decimals, but simplifying may make you avoid those decimals. So 7 over 28 simplifies to 1/4. So my area ratio is 1 over 4, which now I can see, yeah, that's going to be a lot easier to finish filling out my chart from because the square root of 1 is just 1 and the square root of 4 is 2. So my scale factor is 1/2 and my perimeter ratio will be the same thing, remember, 1/2. Now nothing in the problem told me to do this, but I'd always recommend you make that chart. I'm free now to write a proportion, however I have to make sure I pick the right ratio to start with. Since they asked me to find a missing side, I'll be choosing the scale factor ratio to use. If they ask me for area, I'd use the area ratio. If they ask me for perimeter, I'd use the perimeter ratio. So I'm going to do 1 over 2, which is my scale factor, is going to be equal to, well, I know this short side of the smaller figure is 4. Since 4 is the smaller figure, I'll put that on top where the smaller number is from 1 over 2. And then I'm going to set that over x, or put that over x to write my proportion. I'll cross multiply from there and come up with a missing side of 8, and I'll make sure I use the same units, so 8 centimeters for that missing side.